So hey guys, welcome back to my channel. Hope you're doing extremely well. And this is your very own mascot this side. And today we will be solving another POTD. Okay, so today's problem is Boolean Parenthesization, and this question is very important for you guys. As you can see, it is coming in the FANG companies like Amazon, Microsoft, etc. So let us look at the problem. What does it say? As usual. Okay. So it says that we have been given a string of length n, right? And the string consists of T, F, either this one or the OR operator, the AND operator, or the XOR operator. Okay, so string contains either true or false, or either OR, AND, and XOR. Okay, now we have to find the number of ways to apply brackets so that the resulting expression results out to be true. Okay, we have to apply the bracket such that the resulting expression results out to be true. Also, the thing that is not mentioned in the question but that is to be inferred is the T and F are always connected by one of these. Okay, it is never possible that T and F are occurring simultaneously. Then this question will not remain valid. T and F are always like T and F or T and T. Like anytime the two Boolean variables are getting splitted by any of the three operators. Okay, any of the three operators. So let's see how we can solve this problem. The idea to solve this problem, I'm discussing the brute force now. The idea to solve this problem is use recursion, and we consider each operator in the sense or and XOR, each operator as a possible splitting point. Okay, if you're not able to understand what I'm saying, stay with me, you will get the hang of it what we are going to do. And we want to divide the like it is a splitting point, and we will divide the expression into two parts. Okay, splitting point means what? Like this is a string, this is a splitting point, so if we divide it, it becomes this and this, right? So into two parts. Okay, and now our method will be to for each or what do we say splitting point, not only calculate true part, calculate true as well as false, calculate true as well as false. Why? Let me see. Let us see. So suppose my expression is this exp, which after splitting becomes exp1 and exp2. Okay, these are the two expressions that are made. Okay. Now suppose this is these are splitted by an XOR operator. Okay. So what is the truth table of XOR? The truth table of XOR is it's 0 0 0 1 1 0 1 1. Okay. So it returns 0 for the similar ones and 1 for the different ones, right? This is for XOR. We want a final expression to be 1, correct? So if we need the final expression to be 1, we can take two cases. If this is true, this is false, and if this is true, this is false, this is true, correct? These are the two cases for XOR operator. Similarly for OR says any one of them should be true. So for OR, we can take true, 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 false, or false, true, right? And for the AND, we want all of them true, so it will be true, true. But you can see that we will require false also for computing our answers, right? We have to multiply the answers for false also. So we will have to calculate true as well as false. Okay. Now, the recursive function which we are going to write will explore all the possible combinations of parentheses to evaluate the Boolean expression. Okay, let's see how does that work. We will see the implementation now. Implementation as in a pseudo code, we can say so. Implementation. So we will call the solve function. We will make a temporary function as solve, which will be doing our work. Okay, and it will return the number of ways to parenthesize the expression and return it as answer. Okay, so let's see what solve will do. So base condition of solve is if I and j cross each other, that is I becomes greater than j. What is I and j here? I and j are the pointers from which, like, the string was t x or f. This was a string, right? So it is indexes 0, 1, 2, 3, 4. Initially, when we will call solve, we will send 0 to 4 because this is our whole expression, right? And whenever, suppose this is a splitting, so we will only send true and 2 to 4. That is 0 to 0 and 2 to 4. Okay. So whenever I, that is the left part, becomes greater than right part, the expression cannot be valid, right? In that case, we will return false because that is not possible. So the base condition is if I and j, that is I is greater than j, then return false. This is our base case as we always declare in the recursion. Okay. If I is equals to j, if I is equals to j, as in this case, then we have to check the symbol. If it is true, then return true. If it is false, then return false. So for true, it will return true. For false, it will return false. Okay, these two are base cases. Otherwise, what do we do? We declare a variable as answer is equals to 0. Okay, and then we run a loop. Say our looping variable is k, and it will go from I plus 1 to j minus 1, and we will increment k by 2 always. Increment k by, so k plus equals to 2. Why 2? Because you have to skip the operators. Okay, now we will initialize for the looping in the loop only. We will initialize left f, left f, left t, right t, right f. So as the name only suggests, in the left part, what are the number of false? In the left part, what are the number of trues? In the right part, what are the number of trues? In the right part, what are the number of false? Right? As I said, we have to discuss the number of false and trues for all of them. Then we are standing at k. We will be calling the function for I to k minus 1, calling the solve function only, and is true equals to 1, and we will be declare a variable is true and update the left t. Suppose is true equals to 1. So is true equals to 1, that is we will be calling the solve function for true values, and the answer which will come will be assigned to left t, sorry, left t. Suppose is true equals to false, then the answer which will come is assigned to left f, and for right part we will be solving from k to j minus 1, and then is true equals to true, in that case write t, otherwise write f. Okay, after that, if my kth variable is an operator, right, my kth variable will be an operator, that is why we were doing plus 2 plus 2 plus 2 plus 2 to find all the division points. Okay, if it is an and, if it is an and, so what is the condition for and? It the true left t into right t, correct? Because both of them needs to be true for an and operator to return true. In that case, return true, that is left t into right t. This will be a case, right? If it is a XOR, then what will be the answer? It will be left t into right t plus left t into right f plus left f into right f. I will not be explaining why, because I have explained this above only. And for XOR, it will be left t into right f plus left f into right t. Any problem up till now? Are we on the same page? I think yes. And we will update our answer. So accordingly, answer plus equals to answer plus equals to answer plus equals to, and then we will return our answer. This is the solve function we are going to implement. Okay. What is the time complexity for this code? What is the time complexity? A time complexity for this code will be exponential. That is O into 2 to the power n. Why? Because we are exploring all the possible combinations, so time complexity will be exponential. I don't think this statement needs an explanation. Why? because whenever we use a recursion to explore all the possible combinations, the time complexity always goes up exponential. Okay, and the space complexity is O of n. Why O of n? Because of recursive call stack. Okay, we're not using any extra space other than recursive call stack, but it is highly inefficient. You can see the time complexity, it is very much. Okay, what we can do is, whenever there is a recursion with the an inefficient approach, to make it efficient, a hero comes which is known as DP, which is dynamic programming. So yes, we will be discussing the dynamic programming approach now. Please stay with me, stay focused. This question requires attention. Okay. Also, guys, some of the people were asking in the comment section, how does that work? Like, how do you think of, how do you build logic? So, for example, this question, I built logic using the question previously solved question matrix chain multiplication. Many of you will ask how. So I linked it through matrix chain multiplication by, like, in the matrix chain multiplication also I had to link them up with the help of brackets, right? With the help of brackets I have to link them up such that the minimum cost is given to me as the answer, right? And here also I have to link them up with brackets, but here the condition is different. So I just uh, twisted it and I got my answer. I cannot explain how because that is not in my forte to explain my approach right now. But my mind worked like that only. Okay. So we will be using that DP, and in the DP also we will be using memoization approach because that is the most easy approach to fit in a already written recursion. Okay. So what will be our implementation? First, we will be initializing DP with minus ones, right? And we will call the solve function to find the number of ways to parenthesize the expression and return it as our answer. So let's see what is the function doing again, because I have already explained it above. So we'll be doing it again. What will be our condition? Base condition will be I and j cross each other. I is greater than j. In that case, return false. Correct. I is equals to j. In that case, if it is true, then return true. If it is false, then return false. Right. Third condition is to now check dpij now. dpij. If it is not equals to minus 1, then return whatever is there. Okay. After that, initialize a variable answer as 0. Okay. After that, k will move from I plus 1 to j minus 1 with a step of 2. This will be a loop, right? And at every iteration, we have to calculate left f, that is left false, left true, right false, and right true, right? And then we will check accordingly if it is XOR and evaluate our answers as we did above. Okay, so I think this is mostly done with the explanation. Let us just do the coding area because I know that's what you are waiting for, because I also wait for that whenever I'm solving a problem which I don't know. Okay, so if you're liking the video, please give a thumbs up to it. So, and also subscribe to my channel because I am able to see that 90% of the people have not subscribed to my channel. So if you are able to learn anything, let us grow together, let us learn together. So please give a subscription to my channel. So we will be declaring a dp array outside only because that is my style. I like to declare again. I do not like to make it as vector of vector int and etc, right? And we will be writing the solve function here only. The solve will be taking my string and my starting value as I and my ending value as j, right? Also we'll be taking a third variable, which is a third variable which I shared to you, that was is true. If it is true, then it will go into the t portion. It is, if it is not the is true, then it will go in the left portion. So it will be taking int is true because that matters. Okay, so our case was if I is greater than j, that is they are crossing each other. In that case, return false. If I is equals to j, in that case, if is true equals to 1, then return s of I equals to capital T, right? Else, sorry, in that case return s of I equals to capital F, right? Okay. Next step will be to check dp array if it is already filled. So why will we do extra effort? So if dp of ij is not equals to -1, in that case return dp of ij. Sorry, dp of ij true is true also. I always keep forgetting it to mention is true. Sorry for that. Is true. Okay. Now standard procedure int answer equals to 0. Now for int k going from I plus 1, k less than equals to j minus 1, k plus plus, what will we be doing? We will be doing is we will be creating int left f, left t, right f, right t. Okay. After that, if my dp of I k minus 1 1 is not equals to -1, I will check here only. If it is not equals to -1, that is left t is already computed with me. So my left t, oh, sorry, if left t is it is equals to minus, then I will have to compute left t. Left t will be solved for s I k minus 1 1. Okay. Otherwise left t is the dp portion only. Otherwise left t is equals to dp of I till k minus 1 and 1, right? Similarly for the left, right t, right f, etc, etc. Okay. So I will just copy it down and change it to k2 j minus 1, and it will be right t here. From k to j minus 1, k to j minus 1, right t. Okay. Similarly for left f and right f, the only condition that will change is the last one will be changing to 0. Okay. So if else, oh sorry, if else, now we have to compute for left f. This will be 0 here and this will be 0 here. Okay. It will be left f here and it will be 0 here. Similarly for right f, it will be 0 here, 0 here, left f here and 0 here, 0 here and f here. Okay, we have already now we have computed the values of left f, right f, and all the values we need. Now we have to check for the expression where it is splitting. So if sk equals to and, in that case only right t and left t will be multiplied, right? So answer plus equals to left t star right t, right? Else if sk equals to my or operator, in that case also guys, I forgot to tell you, we have to check the is true condition also right here. If is true equals to true, that is it is required to give the true values only. In that case only it will give. So is true equals to 1, in that case return, oh, sorry, answer plus equals to left t star right t, right? Else answer will be equals to every case which will return false. So answer plus equals to left f star right f plus left f star right t plus left t star right f, right? Okay, let us see if we have completed yeah. So and operator is done. Also I will be taking a modulo to avoid bigger values, right? Now for or operators, okay, if is true equals to 1, in that case return true, 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 false, and false true, right? So answer plus equals to lefty star righty plus left f star righty plus lefty star right f. Else answer plus equals to, the only case when or returns false is both are false. So in that case, left f star right f. And after computing else, if and else, answer will be equals to answer modulo 1003. Okay. Else, if or operator is not there, if XOR operator, it is always equals to XOR operator because that is the third option remaining. In that case, if is true, equals to 1. So true case is left t and right f. Answer plus equals to left t star right f plus left f star right t. Correct? Yes. Else the remaining two cases, that is answer plus equals to left f star right f plus left t star right t. Right? And also here also answer equals to answer modulo 1003. Right? Now this is a solve function and we have to just implement the what do we say, the main function. We will be taking this dp and change it to, or change all the values to -1 size of dp, and we will return what do we get value from solve. Right? So we applied deep memorization in the brute force approach as 0, n minus 1 and 1. Okay, because in the starting we want an one value, right? We want a true value. Let's try to compile and run it. Hope it works. Hope it does not give any error. In the meantime, please subscribe to my channel, and as you can see, it is working fine for submit also, and I will upload the same code on the GFG portal, so please take help from there also. And that's all from my side today. We'll meet tomorrow with a new problem and with a new confidence. So have a nice day, and please, if you're new here, please subscribe to my channel because it gives me a lot of motivation. Thank you for watching. Have a nice day.